the last section we're going to be looking at is the idea of difference quotient. And the difference quotient is going to be used to find the average rate of change over a given span h. And so if we basically have like a time interval, or if we want to go ahead and just make it like something like meters or something like that, then we can certainly go through and try to figure out what the average rate of change is over that given interval. And we're going to be using this formula, f of x plus h minus f of x divided by h. So really, this just turns into a big old algebra problem when we go ahead and do this. And so in these examples, what we're going to be doing is we're going to be finding the difference quotient for just a couple functions. And we're going to start off with our fairly basic linear function. So we have 3x minus 5, and we want to find the difference quotient for that function. What we're going to do is we're going to start by substituting x plus h, then we're going to substitute x, and we're going to divide by h. So this is going to become 3 quantity x plus h minus 5, and this is our f at x plus h, minus f at x, which is the original function. That's going to be 3x minus 5. And we're going to divide all of that by h. So I just plugged it right back into this formula. At this point, we're going to distribute. And so I'm going to distribute the 3, and I'm going to distribute the negative to these two terms. And so we get 3x plus 3h minus 5 minus 3x plus 5 divided by h. And now we're just going to go ahead and simplify. Notice that we have a 3x and a negative 3x. We have a negative 5 and a positive 5. And so we end up with 3h divided by h. And we know that h divided by h cancels out. And so we're left with the difference quotient of 3. And essentially what that means is that no matter what span h that we're looking at, that we're going to end up with a rate of change of 3, which actually makes sense because remember our original function was 3x minus 5, which means that the slope of this function is 3 anyway. So what that basically means is we just verified that the slope anywhere on this function is going to be 3. So if we had a graph and it looks something like this, and this is the 0.05, and we had a slope 3, all right, this is really what we're looking at. And no matter where we look at on this function between any span, if that was h, or maybe like this was like h, I'll call that h sub 2, it just means that the average rate of change on that slope or anywhere on that function is going to be 3. Now, it doesn't mean that every single time that we do one of these types of different quotients that we're going to get a specific constant rate of change. So let's take a look at a little bit more rigorous algebraic problem. And so we have 2x squared minus 4x plus 1, and we want to find the difference quotient. And remember, our difference quotient, I'll just write out our formula for this. So f at x plus h minus f at x divided by h. And so what we're going to do is we're going to substitute x plus h and then subtract out the original function. So that's going to give us that we have 2 quantity x plus h squared minus 4 quantity x plus h plus 1. So that's our f at x plus h. We're going to subtract out the original function, which is f at x, and that's going to be this function, which is 2x squared minus 4x plus 1. And we're going to divide all of that by h. All right. Now, similar to what we did in the last problem, we're just going to go ahead and FOIL a whole bunch of stuff. And one of the things that we have to remember is with this animal right here, this x plus h squared, that is not going to be square the x and square the h. We have to turn that into a FOIL problem. All right. So we're going to be really careful when we remember our laws of algebra here. So this is going to turn into 2x plus h, x plus h. I'm going to distribute the negative 4 minus 4x minus 4h. We have a plus 1. And then I'm going to distribute the negative to all 3 of the terms that we have inside of the second bracket for f of x. That's going to be minus 2x squared plus 4x minus 1. And that's all going to be divided by h. Now, if there's any good news, a few of the items are going to cancel out a few of the terms in the numerator. So notice that we have a negative 4x and a positive 4x, so that's going to go away. We have a positive 1 and a negative 1, so that's going to go away. So that helps us out a little bit. We're going to FOIL out this binomial expression right here, okay, or these multiplied binomials. So we're going to have two quantity, x times x is x squared, x times h is hx. We have another h times x. And then finally, we have h times h, which is going to be h squared. We also have our minus 4h from before, and then we also have a minus 2x squared that we're bringing down. We're going to divide all of that by h. All right. Now, these two terms are just going to become a 2hx. And so this just becomes 2 quantity x squared plus 2hx plus h squared minus 4h minus 2x squared divided by h, just by combining those two like terms right here. And now we're going to distribute the 2. So we get 2x squared plus 4hx plus 2h squared. So we just took 2, distributed all 3 of those, minus 4h minus 2x squared divided by h. And similar to what happened before, we get a couple terms cancel out. And whenever you do these difference quotients, you're going to find that a lot of terms eventually do cancel each other out. Okay? So we're going to have 4hx plus 2h squared minus 4h divided by h. And what we're going to do is we're just going to split this up into 3 smaller fractions. We could factor in h out if we wanted to, but I'll just break it up. So 4h squared divided by h plus 4hx divided by h, 2h squared divided by h minus 4h divided by h. And now we're just going to divide. So we get these h's cancel out. We have 2 on top, 1 on the bottom, and then these h's cancel out. And so what we're left with is 4x plus 2h. So notice we had 2 and we had 1, and then finally minus 4. And this is your difference quotient. And this tells us the rate of change between any two values over the span of h. So for instance, if we had the span from 0 to 1, that means that h would be equal to 1, and we would just substitute it back in for h, and that would tell us the average rate of change over that interval from 0 to 1. Or if we had something like from 0 to 2, then h would be equal to 2, or from 1 to 4, that would mean that h is equal to 3. And we would just substitute those values back in, and that would tell us the average rate of change over those given intervals. So hopefully this gives you a good understanding of not only what the difference quotient is, but also, more importantly, how to compute the difference quotient for a function. Given a specific value, we can substitute that back in and then be able to figure out what the average rate of change is over that given span.